flip-flops, and we're going to talk about how they work and what the point of them is. So we're going to start with a D flip-flop, and we know it's a flip-flop because of this little triangle symbol tells us it's a flip-flop and not a latch. And do either of you know what a D flip-flop? Do you need a pen or a pencil? You got one. Okay. Do either of you know what a D flip-flop does?
Whatchamacallit? Oh, no.
Okay. So the output is the same as the input. And the only thing, so it's like, well, why would you have such a thing? Because it only changes on the clock edge. And so it's like it'll store a value for a certain period of time, but then every time the clock edge changes, it changes. And so D, the signal coming in, could be 0 or 1, and the previous value of Q could be 0 or 1. And for a D flip-flop, it doesn't matter what the previous value of Q was. The new value of Q is always just going to be, it's just going to follow whatever D was. So we say that Q follows D. And this one, the change occurs on the positive edge of the clock. That means when the clock goes from low to high. And this will make more sense when we look at a timing diagram.
That means it's not going to change when it goes from 1 to 0, right?
Right, except this, I'm not showing the clock on this table.
Oh, okay.
So yeah, so all this is showing is just based on the value of D and the previous value of Q.
Oh, okay, okay.
Because on some flip-flops, the new value of Q depends on the old value of Q. So this I'll show you. So like if I look at on problem 3, and I want to do the middle one here, where I have, so I have, the top one is just a latch, and the middle one is the D flip-flop we just had. So I'm going to draw these little vertical lines to show me where the positive edge of the clock is. And then the output, this QB, from this middle one, what happens if we assume that it starts at 0, when the clock goes from low to high, it looks at the value of D. And whatever D is, that's the value it takes. And so when it gets here, the value of D is 1, so it goes to 1. And it stays that way all the way until the next positive edge of the clock. And then when it gets to the next positive edge of the clock, it looks at the value of D, and D is 0, so it goes down to 0. And then at the next positive edge of the clock, D is still 0, so it stays 0. And at the last positive edge of the clock, D is 1, so it becomes 1.
Gotcha.
Do keep in mind this is the middle one here. because that one's not actually a flip-flop. Just make sure
Yeah, it's a clock.
it's, yeah, it's actually a latch, and I'll show you how it works after you get done drawing it.
So this main one, or
D flip-flop.
D flip-flop. It's basically just whatever D is, that's what the Q's gonna be.
That's right. And that's going to be the one that you use most often.
Okay.
Now, the next one on the first page is the same. It's a D flip-flop, but it's negative. It's triggered on the negative edge of the clock. And you can tell that from this little bubble right here. So it's negative clock edge. So it's the same table and the same behavior, but when it happens is different. And so I don't know if you remember or not, you had Vidi, he likes to talk a lot about the what and the when. And so the when of this is on the negative clock edge. So the change happens when clock goes
The negative edge.
from high to low. That's right, and that's the negative edge. So if we go back to that problem 3, if I draw vertical lines at the negative edge of the clock, must be QC. If it starts at 0, it's not going to change until it gets to the negative edge of the clock. And when it gets to the negative edge of the clock, it looks at the value of D. Here it's 0, so it stays 0. The next negative edge, it's still 0, so it stays 0. And at the last negative edge, it's 1, and so it jumps up to 1 and becomes 1. And then the top symbol here is not a flip-flop, it's a latch. And you can tell it's not a flip-flop because it doesn't have the triangle. It just has the clock. And what that means is that it's free to change as long as the clock is high. So whenever the clock is high, it's going to do whatever the D input does. And so, but while the clock is low, it doesn't do anything. So it starts at 0, and then while the clock is high, it's going to follow the pattern of the D, and then it's going to just stay wherever it is while the clock is low. But then when the clock is high, it'll follow the pattern of the D input.
So what's its behavior like again?
So its behavior, so the behavior of this one is Q follows D and can change anytime
So like
the
it could,
clock is high.
oh, the clock is high.
Yeah. And so it's not waiting for an edge. Flip-flops change once every clock cycle. Latches can change whenever, and this particular one will change whenever the clock is high.
Remember the clock is high?
And these are like kind of like the basics, or the basic building blocks. Okay.
Yep. The basic building blocks of what you'll be doing in Digital Logic 2.
Right.
Every time it's high.
But mostly it's the flip-flops.
But
But not just when it changes to high, just as long as it's high, it's gonna do, it's gonna follow the same, it's gonna have the same pattern. So the clock is high, like right here, and so it's gonna do exactly what D did right there.
then how does that make it different than?
Because the
Oh.
flip-flop only changes once. See, you can compare it to the one below, and you can see it really is different.
So after the clock is after the clock goes back to low, does it continue on where it is, or
It
does it?
stays wherever it is.
Oh, so that's why it's.
But then,
Oh, yeah, they went on here.
So if you look, you won't be dealing with these much, but I think you might have a homework question. So if you look wherever, if the clock is high, the output is the same as the input. And whenever the clock is low, it just stays wherever it was when the clock turned to low. And that makes it different from the flip-flop, which just changed once when the clock edge, on the clock edge.
Clock is high, is rotating.
So the clock is high here, here, here,
Yeah.
and here. And then, so while the clock is high, you'll have the same output. Q will look the same as D.
Oh, okay. I'll take a picture of it later. I can see it more.
All right. Okay, so now let's talk about the T flip-flop. So, So for the T flip-flop, the value that Q had before is going to be important when T is 1. So when T is 0, there's no change. That means when T is 0, the new value of Q is going to be the same as the old value of Q. So there's no change. So when T is 0, no change. When T is 1, you toggle, which means if Q was 0, the new Q is 1, and if Q was 1, the new Q is 0. So when T equals 0, there's no change. When T equals 1, it's a toggle, which means the new value of Q is going to be the opposite from the old value of Q.
And that's Q old.
This is if Q old was 0, then Q new will equal 1, and if Q old was 1, Q new will equal 0. But that all depends on T being 1. So it depends on both T and and Q. So we don't have that one, we haven't done, that's not in our, the graph that we had. We're gonna do a new timing chart with T.
So that actually just straight up just flips it if it's on. Or if
That's right.
Okay.
There's so many texts. There's so many texts. Okay, so the next one we're going to look at is the JK flip-flop. And the JK flip-flop, let me make sure that I get these right. Let's see. I always get this one. I have a hard time. I'm pretty sure J is set and K is reset, but I just want to make sure. And you'll see what I mean by that in a minute. J is set and K is reset. Yep. Okay. Okay, so if J is 1 and K is 0, that's a set. And by set, that means that Q new is going to equal 1. So J is 1 and K is 0. So that's going to happen here and here. And so it doesn't matter what Q old was. Make sure, because I know that one source on the internet has it wrong.
Every time I try to watch YouTube about digital logic, it never goes well at all.
J1, yes, and I have it in 2 different places. And K1's reset, so 2 places having that. Okay, and now if K is 1 and J is equal to 0, that's a reset. And so the reset means Q new will equal 0. So if K is 1 and J is 0, and again, notice in that case it does not matter what the old value was. If J equals 0 and K equals 0, that means there's no change. So that means whatever Q was before, it's going to stay that. And if J equals 1 and K equals 1, that's a toggle. So it'll just flip-flop what it was from before.
But when you say no change to the old Q?
That's right. Q stays the same.
Okay.
Yep. Okay. So now let's look at the timing diagram of a T flip-flop. So for a T flip-flop, and now it says it's a positive edge triggered. You can have positive edge triggered or negative edge triggered. Since it's positive edge triggered, I'm going to draw little vertical lines on the positive edge of the clock because that's the only place that it can change. And we remember that with a T flip-flop, if T is 0, there's no change, and if T is 1, it toggles. It says assume that Q is initially 1. So I'll start with Q being 1, and then I get to my first positive edge, and I see that T is 0. That means there's no change, which means that Q is just going to remain 1.
So even if we're
Yeah. And now, when I get to the next positive edge, T is 1, that means it's a toggle, so it'll go down to 0. And then when I get to the next positive edge, T is 0, which means no change, so it'll stay at 0. And when I get to the next positive edge, T is 1, that means it's a toggle, and it'll go up to 1.
Wait, this is Q10?
So it says assume Q is initially 1.
Q is initially 1.
So I started with it at 1.
Oh, okay.
And then when I got to the first positive edge, T was at 0, because this is 0, this is 1. When I got to the first positive edge, T was 0, which meant no change. So I kept it at 1.
Well, where does the K, there's no K here or something?
This is just a T flip-flop.
The T flip, oh, it's your third one, where like, oh, when it's 1 you toggle, and when it's 0 you don't change it.
That's right.
Oh, okay.
So as opposed to like the D flip-flop, whereas that one changes no matter what. Or if it's
If it changes,
if
yes.
it changes, yeah. This only flips if it's a 1.
Right,
Okay.
that's right. Which is easy to forget, but
Yeah. We just talked about it, I forgot.
all right. So now we're going to move on to problem 4. Did you want to check yours?
I'll have to check it. Oh, let me see why. Clock was on. Yeah, clock was.
T was 0, so there was no change.
Oh, shoot. T was 0. Okay, yeah. Yeah, but other than that, everything's good.
I think you got the last segment wrong too, because here T is 1, so it has to toggle. Except you would have toggled, it would have been right based on what you had before.
Yeah. Yeah, but thanks for the change. That
Mhm. All right, so now we've got two flip-flops. Y'all probably have not done this yet in class, but we'll go ahead and look at it, what happens when you have these sequentially. You'll be doing a lot of it this semester. So when we get to the first clock edge, which I guess I have, these were positive edge triggered, so I don't know why I have vertical lines drawn at the negative edge, because I'm doing positive edge. So positive edge triggered. But we're going to assume that Q1 and Q0 are both initially 0. And so Q0 is the second one in our list here. And so it's not going to get a change until after the first one is changed. But I'll show you what I mean by that. So let's look at Q1. When we get to the first positive clock edge, we see that Z, which is our input, is 0. Well, D follows Q, which means that it will be 0, and Q1 will stay 0 until the next positive edge. Q0 has as its input Q1. And so when it gets to the first positive edge, it looks at what Q1 was, and Q1 was 0, when that means no change, so it'll be no change. When I get to the next positive edge, I still have Q1. I still have Z as 0, so I'll have no change here, and I'll have no change here.
is this training in like the T clock, or is this something different completely?
This is the D. These are both D flip-flops.
T flip flops.
But what's different about them is that they're in sequence.
Okay.
Like one of them comes after the other. So when I get to the next positive edge, I see that our input is 1. So our first flip-flop changes to 1. Our second flip-flop doesn't change yet because its input is from the one before. And then when we get to our last positive edge, the first flip-flop goes back down to 0, but the second one goes up to 1.
So the Z is the input for Q1.
Right.
Okay. And then the Q0 or Q1
Is the input for Q0.
Okay.
Exactly.
And it's not, well, yeah, it wouldn't be instant because it wouldn't be 1 there because it's not instant, right?
Right. So Q0 happens a clock cycle after Q1. Whatever Q1 does, Q0 does a clock cycle later.
Oh, okay.
What's the difference between? Okay, wait. Okay. I understand what to get Q1. It's just following the regular D flip flop, right?
Right. But then Q0, its input is Q1. So rather than looking at this Z, it looks at Q1.
Oh, then I'll look at the clock. Rather, it's on like here. The clock is on, so it's 1. So that isn't that supposed to?
Okay, so it only changes on the clock edge. So that's why I drew the red vertical line. So what's happening here, Q0 has as its input Q1. So when it gets to the positive clock edge, it looks at Q1 at 0, so it stays 0. Looks at Q1 at 0, stays 0. Looks at Q1. Q1 hasn't actually changed yet because it takes it a little bit of time. So when it looks at it, it stays 0. But when it gets here, it looks at it and it sees 1 and it changes.
So if there was like an infinite amount of like following ones, it would always just keep pushing it back.
That's right. It would be they would be like delayed by 1, and that's what D flip-flops do.
So this is not gonna turn 1 until like this turn backs to 0?
So if I kept going, if I had another clock cycle, this one, so which one is not going to turn 1?
No, what I'm saying is like, you know how like this turn 1, right? But it's you're not, as you said, it takes it time to go to 1. So it remains 0, but it doesn't go to 1 until this goes to 0.
Well, it's because it's what's happening here. It's not because it went to 0.
It's because of
It's
the
because
clock.
it was still at 1.
Okay.
It's because it was still at 1 when it looked at it. It didn't. It was so when it looked at it, it was at 1. It's like if this is the first flip flop, then and our clock edges are here.
Mhm.
Our second flip flop is going to be this one, but just delayed by 1.
And that's where the multiple ones see what it does.
Yes.
Okay.
Stay 0 and you can SI session. What
It's
is
the
that,
same as the
30?
top, just shoved over.
No. Takes the time, so in the second node finally went to 1. It would take a little time for it to go to 0. Yep, there's a second node right there. It takes the time to go 1. Oh, okay.
Does that make sense now?
Yeah, that makes
Okay.
sense. A little bit confusing, but yeah, it makes sense.
And that's exactly what this number 5 is going to show us. So, Q0 has as its input the input for Q0 is the not of what it was before. So if you look at Q0, so here's the not, and that's its input. So it started at 0, but at the positive. So if this is 0, this is 1, and so that's its input, and so it's going to change to 1, and so it'll be 1, and that means Q naught will be 0.
How you're knowing the values?
Does that only change on positive or the positive edge first or not?
Oh yeah, so I did that wrong. Thank you. Because it's what the value is the value is, so hold on. Its input is the not of what it was before. And so
Pretty much just post against every positive edge.
mhm.
How does this value get determined exactly?
Okay, so
Looks in the positive edges, I get
it
that.
looks at the, see its input is Q bar
Yes.
right here. That means its input is the not of what it was before. So when it starts, it's at 0, Q is 0, so the not is 1. And so its input is 1.
Hmm.
And so it's going to be 1. But while Q is 1, Q naught is 0. So when it gets to the next clock edge, it's going to be 0. Okay, so just imagine that I drew here as well, Q naught.
And that's the complementary, right?
Mm-hmm.
That's always going to be the opposite of whatever the opposite is.
Complementary.
Complement just means the opposite. And so when it gets here, it looks at what Q naught was, and it was 1, so it becomes 1. When it gets here, it looks at what Q naught was, and it was 0, so it becomes 0. When it gets here, it looks at what Q naught was.
Then how did you know what Q naught was? That's a
Because it started, it has to be the opposite,
well, the opposite of Q0.
right?
But that's didn't you got Q0 from the
I
not
started Q0 because I already had it drawn, because it's easier that way. But if I didn't, it still has to work that way. I mean, it has to be the opposite. And so if I just did it a little bit at a time, I do have to know that it starts at
Q0?
0, which means that Q0 bar is at 1.
Oh, wow.
Okay? And that's the input for Q0.
Mm-hmm.
And so when it gets here, it sees that it's 1. But as soon as Q0 becomes 1, this is the opposite of it. So it has to become 0. That's how it works.
I get that, but I'm saying, like, how do you know when it turns to 1 and when turns to 0? Is it because, like, I understand
Because they're always opposites, and it's always the input. It's always the input for it. So just watch right here.
Okay.
Okay, right here. We're at a positive clock edge.
Mm-hmm.
Q0, its input is its opposite.
Mm-hmm.
Its input is its opposite. It's now at 1, so its input is 0, so it becomes 0.
Oh.
And then, because this is defined to be the opposite of that,
goes
it
up.
has to become 1.
No, and then it looks at that, and it looks at the positive, so it goes up. Oh, okay, I get that. That's so confusing. Were we taught that in class? I wasn't.
I don't know. But you see it now?
Yeah, I see it. Yeah, it was just kind of like confusing to see. These are all T flip-flops, right?
Yep. Okay, so now Q1 is going to be just like Q0, but delayed. And so it's not going to start until that positive edge. Q2 is going to be delayed by yet another clock cycle. And Q3 is going to be delayed by yet another clock cycle.
I'll just like take a picture of them so everyone's time.
But if you look at those, you can see that Q1 and Q2 and Q3 are the same as the one above it, just shoved to the right by a clock cycle. So that's the only, and so that's what we went over last time. And so each time you add a D flip-flop, so D flip-flops, they transmit the signal, but it's delayed by a clock cycle.
Turns around until it goes up and high. That makes sense.
Okay, for the circuit below, what is the sequence of output values on consecutive clock pulses from Q2, Q1, Q0 equals 0, 0, 0 until reaching 0, 0, 0 again? So we have the input is 1 into all of them. And what does a 1 input do on a to a T flip-flop?
You toggle.
It toggles. And so this would get us, so if we start at 0, then on the next clock cycle they'll all toggle because they all have an input of 1. Except I need to be careful because look at this last one. It's got something weird going on. So let's take a look at what it has going on. It has as its input into the clock the output of the previous flip-flop. So this one was 0. And so its clock is 0. What does a T flip-flop do when the clock is 0?
Stays the same.
Stays the same. So we'd have that. So then on the next one, these will certainly toggle. Yep. And now this one will have 1 as its input and the clock will be 1. So it'll toggle. So it'll become 1. But now it has 0 as the clock again because this is the clock for this one. So for the next clock cycle we'll get 1, 1, and 1 because it won't change because the clock will be 0.
Right.
And the next one I'll get 0, 0, and now we'll get 0 again. Because the clock will be 1, the input is 1, so it'll toggle.
So, functionally, the only thing that kind of matters for this one is the last two, right? Those are the only ones that are going to be...
Right.
Okay.
Yeah, the first one is just going to do 0, 1, 0, and it doesn't affect anything else.
Right. Okay.
I think, is that the last question?
Yep.
Yep. All right. Very good. Thank you all so much for coming. Do you have any questions that I can answer?
I mean,
I came in coming to learn about flip-flops.
I'm just a little bit confused of what exactly here is kind of going on here.